Hello, very good evening and very warm welcome in this beautiful subject of thermodynamics. I myself, Shivam Dixit, welcoming you all in this beautiful series for GATE 2027, where we were discussing about the subject basic thermodynamics in very crisp manner. So, if you recall the previous three lectures, right, so we have talked about the number of concepts that could be asked in upcoming GATE exam. So the first concept that we have discussed, that is properties are exact differential, then properties of ideal gas and its mixture, then temperature measurement or thermometry principle, and then we discuss about the closed system displacement work, and then we discuss about the first law of thermodynamics for closed system, right? First law of thermodynamics for closed system. Today we are going to start with the first law of thermodynamics. See, this part is already done, this part is also done. Now today we are going to talk about these two parts, right? Basically the first law of thermodynamics for steady flow open system as well as unsteady flow open system, right? So let's talk. So first first law for closed system is already done, right? This part is also done. Okay, so now we are going to talk about the first law of thermodynamics for open system, and I hope I have given some of the questions, right, as a homework. I hope that you people have already done that question, and if anyone have any problem, then you can ask me directly in the comment section, or you can ask me in my telegram channel, which is nothing but Shivam sir physics, Shivam Dixit sir physics Wallah. Okay, so in these two places you can ask your doubts. Let me talk about the first law of thermodynamics for steady flow open system. You all know that for open system, like mass transfer is also take place along with the energy transfer. Means work transfer will be there, heat transfer will be there, as well as mass transfer will also be there, right? So mass transfer definitely it will be there, work transfer, heat transfer may take place. Now if I talk about the open system, then here mass balance is also required. Why? Because in case of closed system, the mass is fixed, mass is not changing, right? Even we have solved number of problems where you have seen that the mass was given directly, it was given. Okay, the mass is directly given, but here I'm going to talk about the open system, right? Hello, right? So I'm going to talk about the open system where mass may enter, mass will enter and mass will leave the system, correct? And there might be possibility that some of the mass may accumulate within the system. Okay, let's talk about the mass balance first, right? Now first I'm going to take the case of steady flow, right? I'm going to talk about the steady conditions, and I'm going to talk about the steady conditions. So in a steady condition, what is a steady condition? First of all, we'll try to understand that a flow is said to be steady flow if the properties do not change with respect to time. Properties of the system do not change with respect to time. Or what is system here? That is control volume. So if you have, let's say, I'm considering here, let's say we have one open system kind of thing, correct? So this is basically an open system, just for example, right? This is basically our open system. Now I want to analyze this system, right? So obviously some of the mass is entering from here, let's say m1 dot. See, in case of closed system, we always talk about a given mass, a fixed mass, but here mass is entering, mass is leaving. So here we'll not talk about a given fixed mass, here we'll talk about mass flow rate. Here we'll talk about mass flow rate. So m1 dot mass is entering, at the same time m2 dot is, let's say, leaving. M2 dot is, let's say, leaving, right? Now this is our control volume. This is our control volume. Now please try to understand one very interesting fact regarding the steady flow. Steady flow is saying that the properties of the system means control volume should not change with respect to time, right? now mass itself is a property, means mass of the control volume should not change, and it is only going to be possible when m1 dot is going to be exactly equals to m2 dot. Let me give you one example. For example, this room is your open system, and here 10 kg per second mass is entering. 10 kg per second mass is entering, 8 kg per second mass is leaving, and mass is conserved. So as the mass is conserved, 10 kg per second entering, 8 kg per second leaving, means 2 kg per second mass is accumulating within the system. Means mass of the system, means control volume, is continuously increasing, right? And if mass is changing, then it is not a steady system, right? So the system will be steady only in the case when there is no any accumulation of mass or energy within the system, right? And it is only going to be possible when the mass, like what rate of mass entering must be equal to the rate of mass leaving. So now first of all, I'm going to write here the mass balance, right? Mass balance. Now if I talk about mass balance, my dear student friends, then like for study flow, right? For study flow, I can say m1 dot is exactly equals to the m2 dot. m1 dot is exactly equals to the m2 dot. Clear hai? Any problem? No problem at all. No problem at all. Now what is m dot basically, right? What is m dot, right? Let me tell you what is this m dot, my dear student friends. See, rho is equal to mass by volume, right? Any problem? No problem. Mass is equal to, you can write rho into volume. Volume is area into length. But we are not interested in mass. We are interested in mass flow rate, means mass by time. So we'll divide with time both the side. We'll divide with time both the side, right? So this mass by time is mass flow rate, that is represented as m dot rho a. Now L by time. L by time is what? Length covered per unit time is basically velocity, right? That is nothing but what? Meter per second velocity. So velocity I'm writing with c. Why you are writing with c, sir? Because v is going to use as a volume. Generally we are using v as a volume. That's why I'm considering here c as a velocity. So it will come m dot value will come rho ac. Achha, one more fact I would like to share here. What is specific volume? Specific volume is volume per unit mass. So you can see that rho is mass per unit volume. Specific volume is volume per unit mass. So we can write here v is equal to 1 by rho. So if I write here 1 by in play, or I can write rho is equal to 1 by v. So if I write here, then m dot can also be written as ac by v. Right? This is in general case I'm talking about. Hello, right? So in general case I'm talking about, but for study flow, m1 dot must be equal to m2 dot, means rho 1 a1 c1 is exactly equals to rho 2 a2 c2, or I can say a1 c1 by v1 is equal to a2 c2 by v2. Right? So these three are basically the mass balance equations. Anyone you can use as per your convenience, correct? So there is no problem at all. Okay, let's talk about the energy balance. But before energy balance, I would like to share here what kind of transfers may take place here. So basically you can see that mass is entering, right? Mass is leaving. Heat may enter, like I am considering here positive convention. I am considering here positive convention because as per our convention, heat entering is considered as a positive and work by the system is taken as positive. W control volume dot M. Okay. Now please try to understand here that sir Hindi wali series क्यों रुक गई? No, it is going on, I think so. वो तो चल रही है, मेरा सब्जेक्ट भी हो गया, रुका तो नहीं है. I think applied thermodynamics is going on in Hindi series. I have completed basic thermodynamics in Hindi channel. Have you gone through it? Okay. So now I'm going to talk about the energy balance, my dear student friends. Energy balance, right? Energy balance. So what is going to be energy balance for study flow? Very important. For study flow. So for study flow, it will come E1 dot is equal to E2 dot. Any problem? Means rate of energy entering must be equal to the rate of energy leaving. Because if energy will accumulate, even see, energy of the system is also a property. Heat is not a property. Work is not a property. But energy is a property that we have already seen. dq minus dw is energy, right? So energy, stored form of energy is basically a property. Correct? There is no doubt on this. Okay. E1 dot is equal to E2. What is E1 dot here? E1 dot is basically the rate of energy entering. The rate of energy entering. How much? Yeah, I watch all your lecture. Thank you. Thank you. I think currently applied thermodynamics is going on. E1 dot is equal to E2 dot, my dear student friends. So E1 dot is basically rate of energy entering. Now, if you look at here, the energy may enter in two ways. Energy may enter in two ways. One is, you can see that heat is entering, right? Another one is the energy entering through the fluid. Whatever fluid is, let's say I'm a fluid. Let's say I'm a fluid, Ashutosh Kumar. Let's say I'm a fluid, right? I'm entering. So I have some energy now. I have some internal energy, right? Internal energy. I have some velocity, means I have some kinetic energy. I may have some potential energy, right? Even flow work will be involved. Even flow work will be involved, right? So basically what I'm going to write, that this value I can write m dot, because m1 dot is equal to m2 dot. That's why I'm writing m dot, right? The first one is, first I'm going to write the energy entering through the fluid. Energy entering through the fluid. Through the fluid, four things will be there. One is internal energy, the energy associated, energy inside me. Plus when I entered, my dear student friends, when I entered, right, when I entered, then flow work is also involved, right? Right. So flow work, so internal energy plus flow work is enthalpy. Yesterday I told you, right? See, when I am entering, then internal energy is there plus flow work, that is PV. PV is basically flow work. So basically by these two things, if I combine, then it will become enthalpy. Please try to understand what I am writing, bhaiya. What I am writing? I am writing the energy entering through the fluid. Assume that I am a fluid, beta. When I am entering, then I have some internal energy, and to enter, some of the work is also involved. That is flow work. That is flow work, right? And U plus PV is what? Like internal energy plus flow work is enthalpy. So I can directly write enthalpy. So basically I can say enthalpy is entering, means H1 is entering, plus some of the kinetic energy is entering, half mc square, right? Half mc square, but m is already outside. M is already outside, so I can write plus c square, c1 square by 2, plus mgz. M is already outside, so gz1, right? Plus, so this much energy, my dear student friends, this much energy is entering through the fluid. This much complete derivation we have done in the class, but here that derivation is not required, because that derivation will take half an hour. Correct? The derivation of steady flow energy equation we have already did in the class. That will require how much? But ultimately you have to remember the equation, right? So that's why I'm directly telling you how you can remember the equation. That what kind of energy is entering through the fluid plus energy entering, that is Q dot. Then E2 dot. What is E2 dot here? The energy leaving the system, my dear student friends. The energy leaving. Now energy may leave also in two ways. One is through the fluid. So through the fluid, how much energy will leave? That is m dot into H2, same thing, right? Plus C2 square by 2 plus gz2. Now plus W control volume dot. Clear? Now here also one more interesting fact. See, generally H1 is written in kilojoule, right? H1 is basically kilojoule per kg, H2 is kilojoule per kg, this is kilowatt per kilowatt or kilojoule per second, this is kilowatt kilojoule per second, right? But when you calculate C1 square by 2, it will come joule per second, joule per kg. This term is kilojoule per kg. Listen here. This term is kilojoule per kg. This value will come kg per second. So if you multiply these two, you will get kilojoule per second, because kg is going to be cancelled out. Now, but C1 square by 2 will come joule per second. This value will come how much? Joule per kg, sorry, joule per kg. But actually, you cannot add kilojoule per kg and joule per kg. So you need to convert this term also in kilojoule per kg. So that's why I am dividing with 1000. That's why I am dividing with 1000 to convert joule into kilojoule. Similarly, here also I need to divide with 1000. Then this will also kilojoule per kg. Now each term H1 is small h1 is not a one term. One term is m dot h1. M dot h1, right? Not 100,000 beta Sutosh, right? So m dot h1 is a one term, and that unit is kilojoule per second. This unit is kilojoule per second, no problem. Right, here also you need to do the same thing, right? Here also you need to do the same thing, and this will become kilojoule per kg, this will become kg per second, and this is already given in kilojoule per second. So each term is in kilojoule per second, right? So here I can write here that each term is in kilojoule per second, means or kilowatt. Okay, now 2000 only. I think I have written 2000 only, no? Right, very good, Sujay. Now what I am going to do, Sujay, I am going to divide with m. This is the steady flow energy equation. This is only called as steady flow energy equation, or the first law of thermodynamics for open system steady flow. That is the first law of thermodynamics for open system steady flow. Okay. Now, what I'm going to do? Now I'm going to divide m dot. I'm going to divide with m dot. So you will get h1 plus c1 square by 2000 plus jz1 by 1000 plus Q is equal to H2 plus E2 square by 2000 plus JZ2 by 1000 plus W control volume dot swaha plus W control volume. So this is basically, this is also a steady flow energy equation. This is also what? Steady flow energy equation. Only the thing is, each term is in kilojoule per kg. This is the only difference. So both are steady flow energy equations. Both are steady flow energy. This session is going to be basic to advanced. Yes, Samrat. Very much basics to very much advanced. The only thing is, only one thing is there, right? Only one thing is there, that I am skipping a little bit theoretical part, right? This series is basically for gate perspective, and big derivations also I am not doing here, because it will unnecessarily kill your time, right? Mostly we used to do that in paid classes, but here I'm not doing the derivation, and anyhow, and the derivation which actually required, that I will do, right? The derivation which is for sake of understanding that how it comes, and finally you need to remember the equation itself, then I'm not doing that. Okay, so only you need to remember these two equations, nothing else. Even one equation is also fine. You just remember one equation, that is fine. I can see I am the first year student. Oh, you are a first year student. So first year student, genuine advice you need, so genuine advice if you want, my dear student friends. So this series is going to be very much helpful for the people who have at least gone through basic thermodynamics once in life. Even if he is not taking any coaching, fine, but at least in college they have gone through it. They must aware of the terminologies. They must have like understand the terminologies. If they understand the terminology, then you can attend this lecture. But as you are from the first year, so I'm hoping that I'm assuming that you have not covered this subject even in your semesters also. So it might be little bit problem, right? It might be little bit problem. So two suggestions are there, right? Either you watch some, like there in YouTube itself there are number of series where we have discussed thermodynamics, so you can go through with the other series which we have discussed in detail, right? And the another one is another suggestion, you can watch this, but after watching this 1 hour lecture, at least you need to give 2 to 3 or 2 hour at least through the book, then you'll understand. So let's say you have understand this, no, I have written a steady flow energy equation. Now how this energy is steady flow energy equation exactly comes, that you need to go through with the sum book, because you need to write semester exams also, no, right? If you are going to write only GATE exam and you have already did the derivation in life once, even though you are forget, no issue, then it is going to be very much helpful. But if you want a derivation also, then I'll suggest you to go through with these lectures and then refer some book, right? Let's say 𝐂𝐴𝐻 also fine, Engg, 𝐂𝐴𝐻, whatever you want, you can go through it. Okay, right. Generally in paid classes you need not to refer any book. Why? Because we used to teach even theory also, right? Even theory also, because that is for ESC. Some students are writing ESC, engineering services examination. Some student want theory for their semester exams. Some student wants theory for their junior engineer exam, right? Or any other PSU exam. But this series is basically dedicated for the GATE exam only, right? That's what in GATE exam you also know theoretical part is not being asked, right? 90% questions, technical subject, if you talk about, 90% questions are numerical questions only, and in my subject it is numerical problems only. From last 10-15 years hardly I got any question which is theoretical, right? All questions are numerical only. Okay, you are chartered accountant. Oh wow, so can you file my ITR? Rohit, can you file my ITR? But sorry, I can't give you this responsibility because my wife is also chartered accountant. That is a problem. I don't like chartered accountant people. Hello, I'm chartered accountant and I also watch PW Commerce. Okay, very good. So Rohit, you are chartered accountant. I can give you some work, but I can't. Why? Because my wife is also chartered accountant. And these chartered accountant people, yeah, you know, I can't comment about chartered accountant. Why? Because my wife is there. Otherwise, if she will look at it, if she will watch this, na, she will kill me. She will kill me. मैं सीए वालों से बहुत डरता भैया, मैं चार्टेड अकाउंटेंट से बहुत डरता, मुझे बहुत डर से डर लगता, मैं डर जाता जी. Okay, let's talk about the another perspective. Okay, so this is about, this is the equation. One more small thing I would like to share here, right? One very small thing I would like to share here, that open system reversible work, W open, right? W open, right? In last to last class, right? In last to last class, I have told you that integration 1 to 2 PdV, integration 1 to 2 PdV, right? Integration 1 to 2 PdV is closed system reversible work. Similarly, open system reversible work is minus integration 1 to 2 VdP. That was PdV, it was VdP, right? That was PdV, it was VdP. Now where you can apply? Obviously open system, right? This is only for open system. And steady flow, flow must be steady. It is for steady flow, right? And neglecting kinetic potential energy changes, neglecting kinetic energy and potential energy, and reversible process, right? So these process, right? So these four constraints are there, my dear student friends. These four constraints are there for W open minus integration 1 to 2 PdV. Now if I draw any process in PV diagram, let's say this is any random process, right? Now for given V, right, at given V, if I take a strip, horizontal strip, right, if I take one horizontal strip of dP, then the area of this strip, is equal to VdP, right? Area of strip is VdP. Now total area, this is 1, this is 2. Total area when projected on pressure axis. So total area is equal to integration 1 to 2 VdP, and that is nothing but a magnitude of minus sign is there, which tells us the direction, which is for direction purpose. So this is giving you the magnitude of open system reversible work. Open system reversible work, right? Now if you look at here one very important point, that is the point is very much simple here. The point is very simple. What is that point? The point is PV diagram have 4 statement you have to remember. For PV diagram, how many statement you need to remember? 4. The first one, area under the curve when projected on volume axis. Area under the curve when projected on volume axis in PV diagram gives closed system reversible work. Clear hai? Okay. Then next point, expansion work is always positive and compression work is always negative. Expansion work is always positive, compression work is always negative. The third point, that the area of the cycle gives the net work transfer. Area of the cycle in PV diagram gives net work transfer. And the last one is that area under the curve when projected on pressure axis. Gives open system reversible work. So these 4 things you need to remember. Sir, ये heat exchanger constant pressure पर बनता है? Yes, heat exchanger is constant pressure device. See, practically, if you look at Ashutosh, practically, can you tell me practically? See, it is a reversible case. We are talking about here reversible case. So if any heat exchanger which is reversible, means which is frictionless, in that case it will be constant pressure. Practically, can you tell me whether the pressure will decrease or increase in heat exchanger? Anyone? Ideally, see, in this subject we are talking about ideally only everywhere. So ideally heat exchanger is a constant pressure device and work value will be 0 because VdP, so it is 0. So ideally it is a constant pressure device. Practically whether it will decrease or increase. Whether the pressure will decrease or increase. Okay. Sir, do you remember me? Happy to inform you I got a job in Germany regarding electrical My friend helped me for 50 LPA. Very good, Sai Kumar. See my aura, you can see Sai, right? Even I did not do anything for Sai, but my aura is very big. From last 2 days, Sai is coming continuously in my sessions. And today itself, in 2 days itself, he got 50 lakh per annum LPA in Germany regarding electrical. My student help, my friend helped me. Okay, very good. Congratulations, congratulations, right? Sai Kumar. So you can see my aura, even though I did not do anything, right? But still, Sai Kumar got such a great job. Congratulations for him, and congratulations for your family, because as I know that your family is also struggling a lot for your career, for your education, and I told you yesterday itself, Sai. Yesterday I told you, Sai, don't worry, right? Everything will be paid off, and see, within 1 day it is paid off. Congratulations. Very good. So Sai Kumar, right? When you settle there, you know when you settle there, then just let me know. Then I will come with my family to visit Germany. Okay, because Germany is very good for mechanical engineers. Germany is very good for mechanical engineers, right? Like still you can see that, like NTPC, right? Most of the NTPCs are developed, right? Whatever NTPCs are, they not all, but most of the NTPCs are actually German made, designed by the Germans, and installed by the Germans, and even uh, take care also by Germans, right? So Germany is one of the uh, you know good companies are there. Mechanical, if you look at, for mechanical perspective, it is very good. So Sai Kumar, so I will come for sure to visit Germany after few years. You go settle there. Settle there means you come to India. You don't know, sir, I reach Germany, sir. Now I will not come India. Not like that, right? So you need to come India also. I will also come to Germany for visiting purpose. Germany is for only mechanical. Yes, as far as mechanical engineering is concerned, Germany is ahead of most of the even Japan is also. Japan also very good as per mechanical engineering is concerned. Electronics, if you look at nowadays, current situation is Germany, and especially Germany and even Japan also very good as a mechanical engineering perspective, and electronics perspective nowadays China is doing absolutely fine. Computer science, everyone knows it is a USA, right? All big companies, very big companies are actually from the you know uh, from USA. So congratulations. Okay, so now we'll solve some problems related to steady flow energy equations, right? So basically you also know, right, that open system devices are like nozzle, right? Nozzle, turbine, compressor, pump, heat exchanger, boiler, right? Evaporator, right? Condenser. So all these are basically open system devices. Diffuser, throttling valve. So this is first question. This is the first question which basically involve, like, which basically through nozzle. Once I settle there, I help every student who are poor and struggling because I face a struggle in my life. Yes, Sai Kumar, I know. You told me earlier also that you struggle a lot due to this financial conditions, and finally all your struggles paid off. Congratulations. And helping others will give you a lot of peace, right? Lot of peace. But nowadays one problem is there, yeah, like, even though if you want to help, right? But finding a genuine person who actually need help is a big task, truly speaking, right? Sir, in this happy moment, can you share your Instagram ID? We keep in contact. You just Instagram ID I cannot share in this YouTube session, otherwise it will be a problem for me. Problem for me means problem for everyone, right? So you just message me in a Telegram, right? You just message me Telegram. I will definitely share, right? I will definitely share Instagram ID. I am on Instagram, that is true, but I will share, right? I will share in personally. DM me. Okay. Are Kittu, how are you, Kittu? Kittu aya, where are Kittu beta, where are you? Here I am, how do you do? Kittu beta, where are you? Why you are late, Kittu? Kittu beta, where are you? Here I am, how do you do? My daughter is there. My daughter is 3-year-old. 3-year-old, and if you call her if you call her like her name is Shivi, right? My name is Shivam. Her name is Shivi. So I used to call her Shivi, Shivi, Shivi. She will not respond. She will not respond at all. She will not respond. Now, if you start singing this song, Shivi beta, where are you? Shivi beta, where are you? Then immediately, wherever like she will be, immediately she will start saying, here I am, how do you do? So it is like that. Kittu, I am fine. Aap kaise ho? I am very good. Kittu. Sujay is already joined IIT Bombay Masters, so Sujay is out of your reach. Ashutosh, I don't know. Ashutosh, I think 4th year. Okay, sir, it's our dinner time. I'm in hostel. Oh, hostel. Dinner time. Dinner kya hota? Okay, have you done this problem? Right. So steam at 2 megapascal. So initial condition is 2 megapascal, 300 degrees. Steadily enters into a nozzle. The inlet diameter is given 20 centimeter. The steam leaves the nozzle with the velocity of the steam leaves the nozzle with the velocity 300 meter per second. Okay. The mass flow rate of the steam through the nozzle is given. M dot is also given. Assume no work interaction and no change in potential energy. If the heat lost from the nozzle per kg is also given. Heat loss is also given. The exit enthalpy of the exit enthalpy you need to find out. Right, exit enthalpy you need to find. See, if you look at here, the initial velocity I think not given, right? But you can find out because m dot value is given, right? Right? Is it required to find out? Not required. See, generally, whenever I told you during the classes also, whenever initial velocity is not given, means initial velocity is very less, you can neglect it. So initial velocity you can neglect it here. Initial velocity you can assess C1 is very less than C2 we are assuming. So C1 is neglected, right? Okay, mass flow rate is given. So if I apply steady flow energy equation, then m dot mass flow rate is given 10 kg per into H1. Right? No need of writing C1 square by 2000 because velocity, initial velocity is not given, so we'll assume 0 here. And potential energy anyhow you have to neglect, right? So plus q dot. Now q dot is given the heat loss from the nozzle per kg. Per kg is how much? 3 kilojoule per kg. So plus it will come, and heat is rejected, na? Rejected means minus m dot into q, minus m dot into q, right, is equal to m dot into h2 plus c2 square by 2000. Z we have to neglect, w control volume dot, and this is also 0. Now write the equation. So here it is written that 10 kg m dot value. H1 value is how much, beta? H1 value is okay, 2 megapascal, 300 degrees. H1 value is 3. V1 is also given, na? Area. No, C1 we can't neglect here. Why we can't neglect? Because data is given. When enough data is given, then we can't neglect, because see, m dot is equal to what, beta? M dot can be written as, I have not seen this, right? This is also given. So m dot is equal to A1 C1 by V1. So m dot value is 10 is equal to A1 value is pi by 4 d square, right? 0.2 square C1 divided by V1 value is 0.12551. So from here I will get C1 value. So C1 value you need to calculate. C1 value you need to calculate. If V is also not given, then we don't have any other option. If suppose V is not given, it means we don't have any other option. We have to neglect it. Okay. So now I can say pi by 4 into 0.2 divided by 0.12551, 10 divided by answer. So this value becomes approximately 40 meter per second, right? 40 meter per second approximately. So now here one more term will come, right? M dot into H1 plus C1 square by 2000 minus this one. Okay, now this is the correct equation. So m dot value is how much, bete? M dot value is 10 into H1 value is given as 3024.2 plus C1 value we have calculated 40 ka square divided by 2000 minus 10 already minus q value is 3. Everything is kilojoule per kg, right? Is equal to m dot, that is 10. H2 value we need to calculate plus C2 value is given as a 300. So 300 ka square divided by 2000. Now if you look at here, then it is very easy calculation. 10 is going to be cancelled out. So H2 value you need to calculate. So you will get a 40 ka square divided by 2000. This value will come 0.8, right? Minus 3 plus 30. So this value will come 3022 is equal to H2 plus 300 ka square divided by 2000, 45. So H2 value will come how much? 3022 minus 45. So the correct answer is 2977 kilojoule per kg. Answer they are asking in kilojoule, right? Per kg, right? Per kg they are asking. So 2977 is the correct answer. Just cross check once.
से डर लग रहा।
Solid fast. Now I am going to talk about the only two questions are there. Okay, solve this problem. Everyone solve this problem. Arey Bittu beta, where are you? Why you are late? Why you are late? How do you do? Today Kittu is also late and Bittu is also late. Something is fishy. Hai? Kittu is also gone. Bittu is also gone. Then Kittu also came. Bittu also came. Arey Kittu, Bittu, both are brothers. Kittu, Bittu are brothers actually. That's why they both are, and you both are in the same hostel. Kittu, Bittu. Okay, argon gas, so gamma value will be 1.67. Argon gas entering a turbine at the rate of mass flow rate is given, right? Steadily entering to a temperature given 1000 Kelvin, velocity is also given. Turbine is insulated and the velocity at the exit is neglected. The work done by the turbine, right? Work done by the turbine you need to calculate. Solve it fast. Everyone please solve it fast. Here I think something is missing or something. If something is missing or it can be solved. I think pressure value is missing or what? I think something is missing here. Because if I apply the SFE equation, then C1 value okay, Z we can neglect, Q value will be 0, but H2 value is not given. Nah. H2 we can find out with the help of temperature, but temperature is also not known, and temperature if you put here T2 by T1 is equal to P2 by P1. Without exit temperature, do one thing, here add one more line, right? Exit temperature is 300 Kelvin. Exit temperature is 300. Without exit temperature you can't find actually. Now you can find. Without exit temperature it's not possible to solve. So exit temperature also. Sorry. Have you solved this? Okay. Now I am going to solve here. See, if this is a argon, right, and m value is given, yeah. So if I apply here the steady flow energy equation, then it will come m dot into h1. Now initial velocity is given c1 square by 2000. I'm neglecting this one, potential energy plus q dot value is also 0, is equal to m dot into h2. Kinetic energy at exit is neglected, potential energy neglected, or the remaining is plus wt dot. So we have to find out wt dot. So what is wt dot? Wt dot value you will get, that is m dot into h1 minus h2 plus c1 square by 2000, right? Now for ideal, I'm considering argon as an ideal gas. So for ideal gas, it is CPD, Cp of argon T1 minus T2, CPDT, right? Plus C1 square by 2000. Now what is the Cp of argon, right? The Cp of argon value is, Cp of argon is not given, you can calculate, that is gamma r bar by m into gamma minus 1. So you can write here 1.67 into 8.314 divided by 40 into 1.67 minus 1. So 5.518. 0.518. Yeah, 8.314 into 1.67 divided by 40 divided by 0.67. Right, correct. 0.518 kilojoule per kg Kelvin. So you can add 0.518. So finally I can write here m dot. M dot value is how much? 3 into 0.518 into T1 value is 1000 minus 300 plus C1 square. C1 means 100. 100 square by 2000. 100 square by 2000, right? So what is the value of WT from here? So from here I can say WT dot value will come. Just calculate this. I think this value will come 1102.95 kilowatt. Right, correct. Very good. Very good, very good, very good. 1106. How you got 1106? 1102.8, na? Yeah, correct. Okay. Next. Okay. So this is all about today's lecture. So today we'll learn that open system, study flow open system. So the things that you have to remember from today's lecture, that uh, to analyze open system study flow, mass balance is required, means m1 dot is equal to m2 dot, that can be written as rho 1 a1 c1 is equal to rho 2 a2 c2. And another one that you need actually, that energy flow like energy study flow energy equation. Study flow energy equation is m dot into h1 plus e1 square by 2000 plus j1 by 1000 plus q dot is equal to m dot into h2 plus a2 square by 2000 plus jz2 by 1000 plus w control volume dot. Clear? And then there anything else required? Anything else required? That w is equal to minus integration 1 to 2 pdv. But mostly rarely questions are coming from there. Even the question asked related to w open is equal to minus 1 to 2 vdp can be solved with the help of SFE also. That's it, right? So this is about today's class. So anyone have any doubt, you can ask. If anyone have any doubt regarding anything, you can ask. And if you have still any doubt, technical doubt or non-technical doubt or anything, and which is not covered here, so you can ask me in the comment section. That is one option with you. And the best, even better option is go through with this Telegram channel. So everyone please join this Telegram channel, Shivam Sir Physics Wallah. Shivam Sir Physics Wallah. And if you need any kind of help, you can just let me know. And you just write me, either if it is something personal, then you can write me as a DM. And if it is in journal doubt, if any in journal doubt is there, then you can write in the group itself, right? So that sometime other student also will help you. Okay. Okay, anything else? Bittu, Kittu, Samrat, right? Nabingar wala क्या होता? Sujay, anyone wants to ask anything? Okay. So this is for today's lecture. let's meet tomorrow. This I need to delete. So let's meet tomorrow at the same time. No, tomorrow is Saturday, right? So Saturday no class is there, Sunday also no class. So let's meet Monday. Let's meet Monday on the same time, same place. Okay. Up to that, Jai Hind, Jai Bharat. Thank you. Bye bye. See you. Thank you. Bye bye.